Hello, welcome back to Algebra 1. Here we're going to talk about the crucial topic of adding and subtracting like terms. Now in the last section we talked about that, kind of hinted a little bit to you, until here we're going to talk in great detail. First of all, we need to talk about what a term is and what makes them like and unlike. And then so adding and subtracting part's actually pretty easy. So what if you have an algebraic expression, 3x plus 7? So basically, this is the quantity 3 times x plus the number 7. Now, everything broken up with a plus or a minus sign is what you really call a term in algebra. So this, for instance, is called a term. And this, for instance, is called a term. So anything you see connected with a plus or a minus sign, those are just called different terms. Now we have to ask ourselves, are they like or unlike terms? Let me ask you, do they look like terms? Well, I mean, they do have numbers, that's true, but you see this term has an x, and this term has no x, it has no variable at all. So because they don't have the exact same variables there, these are what you call unlike terms. So I'm going to write that down here. These are unlike terms. It turns out in algebra that you can only really do this addition if these actually are like terms. You know, like if I have a bucket of apples and then another bucket of apples, I'm allowed to add those apples to the other bucket and sell them, right? So I may have 10 in one bucket, 15 in another bucket, I can add them together. But if I have a bucket of apples and then a bucket of jelly beans, I mean, I can add them together because, yeah, I can add any numbers I want, but it won't make any sense if I add apples to jelly beans. I mean, who wants to buy jelly beans and apples? Or maybe a better example would be apples with, forks, right? Who wants to buy those together? Or something crazy, cotton balls, something, towels, right? Yeah, I can add the numbers, but it doesn't make sense unless the units match, unless the object matches. And in this case, the object here is this is 3x's, 3 times x, and this is 7, just 7 by itself. So there's no x involved here at all. So yes, there are numbers here, but don't try to add these numbers together because these are unlike terms. It won't make any sense. And in algebra, it's more than just not making sense. It's not allowed. You can't add them together unless these are what we call like terms. So let's take another example of something a little bit simpler that I know you're more familiar with. What if you have 7 plus 2? Are you allowed to add these or not? Well, yes, of course you are. The answer is 9, right? Because this is a term and this is a term. Let me ask you, are these like terms? Yes, they are. These are like terms. I know that you look at this and say, well, this is obvious. These are numbers. Well, you see, there's no variable here and there's no variable here. So because they basically match in terms of the variables that are there, in this case there aren't any variables, then you can add them and you get 9. And notice the answer doesn't have any variables there at all. This is just basic addition from, when you were a little kid. Now let's go on and look at something more like algebra. What about 3x plus 2x? Do you think these are like terms or not? Well, this is a term here, and this is a term here, and these are in fact like terms. And what makes them like terms? It's not the numbers. The numbers can be totally different. It's because there's an x here and there's an x here. And these x's, we're going to talk about exponents later. There's really no exponent. Really, there's an exponent of 1 up there in both cases. But the variables have to match and the exponents have to match too. We'll talk more about exponents later. In this case, the basic idea for you to understand is in order to say that they're like terms, the variables have to completely match. They have to look exactly the same. In this case, there's an x here and there's another x here, so these are like terms. Now, if you were to add them together, what are you going to get? Well, all you do is you add the numbers. 3 plus 2 is 5, and you have to carry an x along for the ride. So you see what's happening is this is 3 x's, and this is 2 more x's, and you add them together, and what do you get? You get 5 x's. That's kind of how to represent that in your mind. Or you could say this is, 3 apples and 2 more apples, so the answer is 5 apples. So the variable is going to just come along for the ride and match what you were adding together, and then actual numbers are what's actually added together. So now that we've got sort of the theory out of the way, let's go over here to the right and just do a bunch of these things, and you'll get the hang of it from experience. What if you have 6a plus 3a? Question, are these like terms or not? Yes, they are, because you have a right here and you have a right here, and they exactly match. So because of that, you can add 3 plus 6 and get 9, but a has to come along for the ride too. It has to match, just like we've been saying. What if you have 2a plus b plus 6a. How do you simplify this? Well, you see you have two a's here and you have 6 a's here. So these terms are like terms. But the b is completely different. It's unlike those two. But I can still add the like terms. 2 plus 6 is 8a. I got to carry a along. But I still need to write this plus b because I couldn't really do anything with him. And this is the final answer because this term is unlike this one. This is an a and this is a b. You can't add them together because they're unlike terms. Hopefully you start to get the hang of this as we start doing them. All right, so that's 8a plus b. Now what if you have, let me change colors here a little bit. What if you have negative a plus 10a? Are these like terms or not? Well, don't let the negative sign scare you. That's the sign of it. Really, there's a variable called a here. There's a variable called a here. So that means these are like terms. So I can add them. Now, really what you have is this is negative 1 sitting out in front of the a. And this is 10. So this is negative 1 plus 10. How do you add those together? You're going to get 9, and then you're going to have a. Now, how did you know it was 9? Because since this is negative 1, you're adding negative 1 to positive 10. You subtract them, getting 9. The sign goes with the larger absolute value, so you get 9, positive 9. And then the a comes along for the ride. So you see you're building and you're using the things that we've learned in the past almost for every single problem now. So what if you have negative 2a plus 3a plus b plus negative 7b? So how do we simplify this? Now this is interesting because I have, here's an a and here's an a. So these terms are like terms. Now here is a b, that's a term, and here is negative 7b. So these variables match. So these are like terms here, and separately these are like terms. So we can add these together. What is negative 2 plus 3? That's just going to be 1, right? So it's going to be 1, and a is going to be coming along for the ride. So there's kind of an implied 1 right in front of the a here. And then you move your attention over to here. You have 1 plus a negative 7. How do you do that? That's going to give you negative 6, and b is going to come along for the ride. So make sure you understand that. So what's happening here, basically you have 3 plus a negative 2. So you subtract them, giving you 1, and the sign is going to be positive because of that. And then a comes along for the ride. So you have 1a. Here you have 1 plus negative 7. Again, you subtract them. 7 minus 1 is 6. The sign comes from the larger absolute value here, and b comes along for the ride. So you have a minus 6b. You can't do anything more with this because they're unlike terms. A and b are totally different. All right, so let's go and just do a couple of additional ones. What if we have 8a minus 6b? Oh, I'm sorry, not 6b. 6a. Are these like terms or not? Yes, they are, because you have an a in each. And the variables match, which are a here. So what do you have? 8 minus 6, that's easy enough. That's just going to give you 2. And the variable a comes along for the ride. And then our final problem is going to be negative 7x minus 9x plus b. So again, we have like terms here because the x's match, but this is totally unrelated. So that's kind of off in the weeds. But these guys we can handle. So what you have is negative 7 minus 9. So you have a negative minus a number, or plus a negative 9 is another way to think about it. How are you going to get that? Well, basically you add the numbers. 7 plus 9 is 16, and when you add two negative numbers together, because remember, this subtracting 9x is like adding a negative 9, you add the numbers and then the sign's going to be negative for when you add two negative numbers. So you'll have negative 16, and then x comes along for the ride, and then you have plus b. And this is going to be the final answer, negative 16x plus b. And you can't do anything more with this because you have an x here and a b here, so these variables don't match. These are unlike terms. So again, negative 7 minus 9x would be the same as plus negative 9. So negative 7 plus negative 9. From previous work, we know that that's a negative 16. The x comes along, and then you have the b there. So we're starting to get a little bit more looking like real algebra problems here, you know? And so everything that we've done in the past as far as adding and subtracting numbers, and now we're learning about like and unlike terms, and basically once you understand like and unlike terms, then you start adding a bunch of things, and your skills with adding and subtracting real numbers, it becomes very, very important. So make sure you can do every one of these problems. Follow me on to the next lesson. We're just going to get a little more experience and practice with this so you can build confidence in these types of problems.